Assalamu alaikum students. How are you? I hope you are learning the concepts as concepts are the building blocks of this subject of mathematics. So in that regard, our today's topic is what is scientific notation? That is the commonly used concept in different branches of science, especially in mathematics, physics and chemistry. Let's understand the meaning of it first. What is scientific notation? Notation means a system of writing uses symbols or symbolic expressions. Symbolic expressions. Whereas scientific means based on principles of science. It means the meaning of the scientific notation is a system of writing uses symbols or symbolic expressions based on principles of science. So now we have the meaning of scientific notation. And now we understand the meaning of the scientific notation as it is widely used in science and technical work. And mostly used by scientists, mathematicians, and engineers. So scientific notation is a system of writing numbers, uses symbols or symbolic expression based on principles of science, using science and technical work and used by scientists, mathematicians and engineers is also known as scientific form of writing numbers. Now we clearly understand the meaning of the scientific notation. But still, a question arises in the mind of the students that what is scientific notation? Actually, scientific notation is a method to express very large or very small numbers. And what are these very large or very small numbers? Let's discuss. We try to understand this concept with the help of few examples. Very large numbers are also considered as astronomically large. Astronomically large. As you're a little bit familiar about astronomy, the distance of the different planets and the stars is a very large quantity, which is a little bit difficult to express in the standard form. So we use this scientific form. Let's take some examples. Distance of Earth to the Sun is 100 million kilometer. This is a little bit large quantity to express. So if we convert it into the scientific form, so that will become 1.5 into 10 raised to power 8. That will a little bit easy to express. We take another examples from the sciences, that is Avogadro's number Z6000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000000. a zero, then the value will become wrong. So the easy, precise and comfortable way to express such a large number is the scientific form, and that is for this is 6.022 into 10 raised to power 23, about which every science student is very familiar. Let's take another example from physics, and that is mass of Earth. Which is 5972 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21. So 21 zeros are required to write the exact value of the mass of Earth in kilograms. So it's a very huge quantity to express. So the easy way is to express like that: 5.972 into 10 raised to power 24, which is approximately considered to be equal 6 into 10 raised to power 24 kg. Now this way looks easy to understand, rather than we write so many zeros along with it, which may confuse us. If we miss any single digit, the whole quantity will become incorrect. So these are the few examples which help us to understand the large quantities like 1 million kilometer, or like this quantity of Avogadro's number and mass of Earth, to understand how useful method of scientific notation is to express the very large quantities. These are astronomically large. So let's discuss few examples of very small quantities which are considered to be microscopically very small. Very small numbers which are considered to be microscopically small. As science students are familiar with microscope, which is used to observe very small or tiny objects, like a smallest bacterium. The size of the bacterium is size of the smallest bacterium is 0.12345 zeros and 2 meter. So it is a very small particle which is about 2 micrometer. So it is little difficult. Again, if we miss a single zero, so that value will become different from the original. So hence the easy way to understand is we write in scientific form like 2 into 10 raised to power minus 7 meter. Let's take another example from chemistry. As it is very difficult to measure the weight of an atom, as it is very tiny particle. So its value is very small. So let's understand by writing its value. The weight of an atom of hydrogen is 0.1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 1, 7 gram. Again, the number of zeros are too many. So therefore, if we miss again, what happens? We miss the right value. So hence, to write it in a precise and easy way, that is the scientific form. And how we can write 1.7 into 10 raised to power minus 24 gram. So you observe that too many zeros or the short way. You will find it easy to write the numbers in precise or short way, that is scientific form, much easier. Let's take another example from physics. As we are familiar about the universal gravitational constant. Universal gravitational constant. And that is 0.0000000006673 Newton meter square per kg square. That value is very small again, and it is easy to describe in such a manner like 6.673 into 10 raised to power minus 11 Newton meter square per kg square. So now you become familiar that the scientific notation is actually a system of writing different very large or very small numbers by a precise, short, brief and easy way. And that method is now we are going to learn how to transform the numbers written in standard form into the scientific form. But before this, we learn this transformation of standard form to scientific form to standard form. So first of all, we have to understand a very important part of this scientific notation, that is in actually in exponential form or index form. That is, each number written in scientific form consists of a part written in 10 raised to some power. So it means, first of all, we have to understand the index form related to 10 raised to power. So let's discuss what is index notation. As we know that, for example, a number written 2 raised to power 5, that is 2 multiply 2 multiply 2 multiply 2 multiply 2. 2 raised to power 5 means 2 is multiplied 5 times. That is equal to 32. So 2 raised to power 5 is the index notation of 32. Similarly, if we have 3 raised to power 4, so that is 3 into 3 into 3 into 3. So 3 is multiplied 4 times, that index notation means. So 3 3s are 9, 3s are 27, 3s are 81. So 3 raised to power 4 is the index notation of 81. Now we are a little bit familiar about the index notation. We have to discuss the index notation with respect to base 10. So let's do it. As we know that 10 raised to power, if we have 0, that is equal to 1. mean no zero written along with 10. If 10 raised to power 1, that is equal to 10, so 1 0 is written with it. 10 raised to power 2, that is 10 multiplied 10, that is equal to 100. The two zeros written along with 10. So 100 is the index notation of 10 raised to power 2. 10 raised to power 3, that is 10 multiplied 10 multiplied 10, and that is equal to 1000. So three zeros are written along with it. And 10 raised to power 6, that is 10 multiplied 10 multiplied 10 multiplied 10 multiplied 10 multiplied 10. 10 multiplied 6 times, that is 1 2 3 4 5 6. 6 zeros are written along with 1 for 10 raised to power 6. 10 raised to power 9, that is equal to 1 2 3 4 5 6 7 8 9 zeros written along with 1. 10 raised to power 12, that is equal to 1 2 3 4 5 6 7 8 9 10 11 12. So 12 zeros written along with it. As we are familiar about these numbers, that is 10, 100, 1000, and that is 1 million. 1 million. And that is 1 billion, in which 9 zeros are written along with 1, and that is 1 trillion, where 12 zeros are written along with 1. So these are very much familiar numbers which are used in mathematics as well as in real life. So it means we have to familiarize with these numbers with the basis of 10 as well. So these are the positive numbers discussed. Let's take some numbers which are small with respect to the base 10. If we have 10 raised to power minus 1, so that is 1 over 10. As we change this minus, take this value in denominator to make it positive, so that is 1 over 10, and in decimal form that is 0.1. 10 raised to power minus 2 means 1 over 10 raised to power 2, that is 1 over 100 is equal to 0.01. 10 raised to power minus 3 means 1 over 10 raised to power 3, that is equal to 1 over 1000, that is 0.001. 10 raised to power minus 6, that is 1 over 10 raised to power 6, and that is 1 over million, that is 0.000001. Mean that is 1 millionth part. That is 1 millionth part. 10 raised to power minus 9, that is 1 over 10 raised to power 9, that is 1 over 1 billion, and that is equal to 1 2 3 4 5 6 7 8 1. 1 billionth part. If we have 10 raised to power minus 12, that is 1 over 10 raised to power 12, and that is 1 divided by 1 trillion, 3 4 5 6 7 8 9 10 11 12, and that is 1 2 3 4 5 6 7 8 9 10 11 12. So 11 zeros are written before 1 to describe 1 trillionth part. These index notations are also very commonly used as prefixes in sciences. Like 10 is known as deca, 100 is known as hecto, 1000 is known as kilo, which is very famous. 1 million is known as mega. 1 billion is known as giga, and 1 trillion is known as tera. Similarly, these are also very useful quantities which are used as prefixes in index form. 10 raised to power minus 1 is known as deci. 10 raised to power minus 2 is known as centi. 10 raised to power minus 3 is known as milli. 10 raised to power minus 6, 1 millionth part is known as micro. 10 raised to power minus 9, the 1 billionth part is known as nano. And 10 raised to power minus 12, 1 trillionth part is known as pico. These are familiar terms in prefix. These are the widely used terms of prefixes which are also written in index notation, which is relevant to the scientific form. It means we have to better understand not only these prefixes as well as these index notation to understand the scientific notation in a better way. As we are a little bit familiar about the index notation of base 10, so let's discuss the definition of scientific notation first. A number written in the form m into 10 raised to power n, where 1 is less than or equal to m is less than 10 and n is an integer. In this expression, m is named as significant, whereas n is named as order of magnitude. What is the meaning of this expression m into 10 raised to power n? That is, m times 10 raised to nth power of 10. So let's understand this expression with the help of some examples. Let's take a number 3000, that is equal to 3 multiply 1000. And as we know that 1000 is equal to 10 raised to power 3 in index notation, so we can write as 3 into 10 raised to power 3. So 3000 is 3 times 10 raised to power 3. Mean 10 raised to power 3 is multiplied 3 times. We take another number for better understanding, that is 0.05. We convert it into fraction, the decimal number 5 over 100, and that can be written as 5 over 10 raised to power 2, which will be equal to 5 into 10 raised to power minus 2. By the concept of this, mean we have 1 over 100 is equal to 10 raised to power minus 2. So it means 0.05 is actually 5 times the 10 raised to power minus 2. So in this way, with the help of examples, we learn the exact meaning of the definition of scientific notation. Let's do some examples to understand the conversion of a given number in ordinary notation to scientific notation and a given number in scientific notation to convert into ordinary notation. Let's take some examples. 205000000. We know that the original position of the decimal point in such a number after the last digit right here, we use a symbol named as reference position. Reference position for better understanding. So, how to convert this number in ordinary notation into scientific notation? So, first of all, we have to recall that the number in scientific notation should be in the form m into 10 raised to the power n, where m is significant. So, it means we have to write significant first. And how we write significant? For this purpose, we have to remove the decimal point. So its position is relocated. So how we relocate this? In this number, we move the decimal point from this position to the new position after 2, which is the first non-zero digit from left hand side. So we write significant as 2.05. So decimal point will be relocated after 2 and we get the significant 2.05. And the second part consists of 10 raised to the power n. And how we write that 10 raised to the power n? Order of the magnitude is obtained by counting the number of digits lying between reference position and decimal point. It means the value of n is 8. Why? Because the decimal point, original position of the decimal point is on the right hand side of the reference position. Therefore, the value of n is positive and we write 10 raised to the power 8. Let's take another example. 0.00000043. How we write such a small number in scientific notation? So first of all, we have to gather the significant, mean the first part, significant. So for this sake, we place a reference position after the first non-zero digit from left hand side, that is 4 in that case. So we write significant as 4.3. So decimal point will acquire the new position after 4, between 4 and 3. So the significant is 4.3. The next part, which is in the form of 10 raised to the power n. So it means we have to gather the power of 10, mean the value of n, and that is the number of digits lying between reference position and decimal point, and that is 1, 2, 3, 4, 5, 6. But we write -6 over here. Why? Because the decimal point lie on the left hand side. Decimal point lie on the left hand side of the reference position. Therefore, the value of n, mean the power, the order of the magnitude is -6 and we write here. So hence, 0.000043 is equal to 4.3 to 10 raised to the power -6 in scientific notation. Now we move to the conversion of scientific notation to ordinary notation. For this purpose, we take a few examples. Let's take a number 3.74 into 10 raised to the power 5. In that number, first of all, we have to remove the decimal point from significant and we write as 374. In place of the decimal point, we write reference position between 3 and 7 and the power 5, that is the order of the magnitude, will tell us how many zeros we put after that number. As we know that the number of digits lying between reference position and decimal point are determined by that power, so that is 5. So we count the number of digits after reference position 7, 4, and it means 3 more zeros are needed to write the number in ordinary notation. Now we know that the decimal point will be right here, and the number of digits between these two, 1, 2, 3, 4, 5, mean n is equal to 5, verify. So hence 3.74 into 10 raised to power 5 is equal to 3,74,000. Let's take another example, that is 9.24 into 10 raised to power minus 6. How we write this number in ordinary notation? So first of all, again we have to remove this decimal point and write reference position in place of that. We write 924, leaving some space. Why? Because the power is negative. It means the decimal point will actually lie in the left hand side of the first non-zero digit. So therefore we leave some space over here to put zeros in standard notation. As we know that the number of digits lie between reference position and decimal point determined by that power minus 6, we write reference position after the first non-zero digit from left hand side in place of that decimal point. Now we have to count the number of zeros. How many zeros we put over here? As the power of 10 is minus 6, it means we have to count 6 digits before that reference position. So 1 is already there. We put 1, 2, 3, 4, 5 zeros. To write the number, we put the decimal point before this, as we know that the number of digits lying between the reference position and decimal point is 6. So n is minus 6. N is minus 6 determine us that the decimal point lie on the left hand side of the reference position. Left hand side of the reference position. If n is positive, so decimal point lie on the right hand side. To highlight the decimal point, we place 1 0 before the decimal point. So I hope you understand the conversion of a given number in ordinary notation to scientific notation and a given number in scientific notation to ordinary notation. Thank you very much.